So for example 5, we've got a farmer fencing in 3 adjacent rectangular corrals using 200 feet of fencing. Let X equal the width of each corral. You can see the diagram. You can see what X represents right there. If all 200 feet of fencing are used, write an expression for the length of the entire fenced-in region in terms of X. So we're going to be looking for this length right here. All right, so to do it, we're going to need to label all the pieces of the fence. So this piece is X, this piece has a length of X, and this piece has a length of X. So these are the widths. And we'll call the distance across the top, the entire top, Y. So we have 2 of those. We have one down there, and there's another one down here. So this also is Y. It's a funny Y. Y, I did it again. So Y. So when I express that, adding up all the different pieces, I get that 4X plus 2Y's are going to need to add up to our 200 feet of fence. So that's going to be equal to 200. And we want to solve Y in terms of X. So I'm going to move my X over. So I get 2Y is equal to 200 minus 4X's. And then because I have 2Y and I want to know what Y is, I will need to divide everything by 2. And I get that Y is equal to 100 minus 2X. So that's what's going to represent this. 100 minus 2X is going to be the distance across the bottom. All right, so now we want to write an expression for the area of the corral, so the whole thing. So width is X, so the area is going to be equal to X times the length, which was 100 minus 2X. Now the question is A positive or negative? Really, to figure this out, our first inclination is to say positive because this is a 1, and we know that that's the same. But this is a little bit tricky right here. It's not X minus, so this is really not totally in factored form. So I'm going to distribute this. So I'm going to distribute this and change it to standard form, so that I'm going to have A is equal to 100X minus 2X squared, and I'll rearrange it so it's in standard form. So area is negative 2X squared plus 100X. So we can see here that the little a is negative, and that this is indeed a parabola that opens downward. So so the a is negative, and therefore it opens downwards, and that means that we're going to have a maximum in our problem. So how wide is the corral? I'm not real sure what they're asking there, but I'm going to say X. It's X wide. And what is the maximum area? So I want to find the maximum area for this. And to find, remember, a maximum, I need to find the vertex, because the maximum on a quadratic equation always occurs at the vertex. So for our vertex, we need to do axis of symmetry. So negative b over 2a. So the opposite of b is going to be a negative 100 divided by 2 times negative 2. That's negative 4. And I get 25 for my value of x for the vertex. And then to figure out what the area is, again, I have my choice. I can either plug it in here to standard form or go back to this factored form, and I prefer this one. It does not matter which one you choose. So I'm going to say then, so A is X, which is 25, and again, I'm using this one. And then I have 100 minus 2 times 25, which is 50. So I get 25 times 50, which is 1,250 is the area. So if we made a statement, we'd say that he would have a maximum of 1,250 square feet possible when he makes the width 25 feet. So keep in mind what X represented. X represented the width of the whole thing. So when we found X down here, that's what we are finding. I want to point out now that we've had several of these rectangle problems with area where we had to calculate what y was equal to. So that should suggest pretty strongly to you that you will see that on the test.